without further ado, we have our keynote speaker for day 2. This is Amanda Walker. I've had the privilege to work with her across a couple of different companies now. And for some reason, she still takes my phone calls and agreed to come talk to us about something that's, I think, pretty exciting. I will ask you all to put your hands together for Amanda Walker. And let's hear what she's got to say. Thanks a lot. The slides were working early. There we go. Okay. Hello, everyone. My name's Amanda Walker, and I'm going to talk a little bit about logs and time series, beyond logs and time series, and observability for security and privacy use cases. I'll start out with a little bit of an intro. I'm currently at Google leading applied research for privacy, safety, and security. Before that, during the pandemic, I spent a few years working for a small company called Nuna, which gave me the other end of the spectrum from Google, of a 150-person company with a 10-person infrastructure and security team. Done some work at a host of prior companies, some of which I've met some of you. But I want to make one important statement here is while I currently work at Google, this talk is not about Google. So this is not a story of how we do things there. A bunch of the principles I'll talk about are ones we do apply, but I'm not going into tooling, things like that. This is more of a trying to get some guidelines on how to think about observability from a security standpoint and through a security lens, regardless of what tooling you're on, regardless of what platform you're on. So, we'll talk a little bit about observability. I know some of you are familiar with the concept, but it's something that's gotten very popular in the SRE community, where basic, traditional logging and monitoring is no longer really sufficing, and so reframing of how you keep track of a system in production and understand what it's doing has sprung up under this term observability. This came from control theory, and if you go to Wikipedia, you get a nice control theory definition, which is how well internal states of a system can be inferred from knowledge of external inputs. And really what that means is you can tell what's going on without having to stop and take it apart. You're not just looking at things from the outside. So how do we do that? The first place to start is logs. We're all familiar with those. They record what happens. They tend to be events that happened in the past, and they're used for evidence after the fact. You can't prevent anything with a log. It merely tells you some things that happened so that you can go try to reconstruct how you got there. Building on top of logs are alerts, which are more timely. This is something that fires when a condition's met. And I'm just defining these as terminology so that we all understand what I'm saying for each of these. And the alerting criteria are always specified in advance. There's something you expect to happen or are worried will happen, and so you write an alerting rule that fires when those conditions are met. Usually triggering some kind of process based on that. And these two have been thoroughly used in production, in security over many years. Most platforms come with logging and alerting. Centralizing that has been an entire sub-industry for a while, but that still doesn't give you a lot of information in the moment. Maybe 10, 15 years ago, people started thinking more in terms of telemetry rather than recording events that happened. Get snapshots of a system state at a given point in time. Do that at repeated time intervals so you can see trends over time. Time series databases became very popular at this point, so things like Prometheus and systems like that can store things over a lot of time, let you perform queries either by time or by signal, draw pretty graphs on them, things like that. This revolutionized monitoring because you could sort of see the state as it was progressing. You could see request counts climbing. You could see latency increasing before it hit some alerting threshold. And the big innovation here was that the logging and alerting conditions were separated from gathering the data. Traditionally in logs, you emit a log statement in code. You say if such and such has happened, or if I hit this function, you emit a log statement, or test a condition and generate an alert that way. Very hard to change. Required pushing a new binary, all of that. If you instrument something with metrics and then have an engine running on top of that, looking at the metrics coming into your time series, you can then separate that. You can tune metrics. You can silence alerts. You can create new ones without having to push something new into production, things like that. Because this is capturing behavior, not just state. You can see how the state evolves over time and deduce things from that. So this is sort of a step more abstract. But it's still slicing things across time. And so you get a snapshot, and you get another snapshot, and you get another snapshot, and you still kind of have to stitch things together. So if you're looking for more granularity than, okay, what's the load on my server, or how many API calls per second am I getting, things like that, you need to slice things in a different way. Tracing is the most recent of these approaches, and this is really what most companies and most organizations that are focused on observability take as one of the distinguishing pieces, which is tracing slices across a context instead of time. So you can follow the path of a request. Say, okay, I've got a request hits my web server. Which of the dozens of microservices that I am running does this request flow through? Does the data come back through? What credentials are used? You can follow things like that. And so it's much more focused on causal relationships. So request came in, did this, did a database lookup, did that, and so on. This is useful for debugging. This is useful for troubleshooting problems that are happening right now. And it is, these three pieces are usually called the three pillars of observability, or sometimes MELT, which is metrics, events, logs, and traces. You'll hear a lot about that. These are the basic pieces of it. And what all of this gives you when you combine all of these is something very important, which is you can start to answer questions about your system with queries rather than investigations. One of the challenges of working in security, especially on defense, is it can be very hard to figure out what happened. Something happens, you get evidence of something, an event, and then you have to go back and reconstruct. And you can often have to interview engineers, go look at code. It's a very time and toil intensive process. If you can query these things from the system directly, that reduces a lot of toil, that increases your ability to stay focused on the problem, visualize what's going on, and so on. And questions are situational. They're not known in advance. They're not something you could have written an alert to anticipate. You couldn't have written a log analysis pipeline to surface. They're questions you have right now, often based on questions you just asked and got some answer to. And so you can anticipate what types of questions you need to ask, though. So things like pivots and joins. So I've got a suspicious session going on. It's like, okay, Joe has not logged in from Singapore. He's based in New York. This might be a suspicious session. I want to look at his credential. I want to say, okay, what was that credential used for since time X or in this user session? So you're pivoting on that. You may want to pivot on the geolocation. You say, okay, is there other suspicious activity coming in from there? All of these kinds of things are very sort of data analysis tool centric. They're things that haven't been traditionally applied in a generic fashion to production data, to security data until recently. You also want to do expansion and narrowing of scope. If you try to look at all of your traffic or all of your activity in a very complex system, especially when distributed across a lot of different services, it can be very hard to see signals in the noise. And so the ability to expand or narrow scope as you have more questions, as you do these kinds of pivots and joins, is very important. You want to say, okay, I want to focus just on this session, just on this user credential, just on this type of user credential, just on this subsystem, and see where all of the requests coming in and out of it are, things like that. And visualizing this helps a lot. We all have eyes, we've probably all had times when our eyes have glazed over reading log messages, scrolling through things, trying to keep track of what we're looking at. And so the ability to take these kinds of queries and visualize them is important. And one of the things that I've noticed in working with teams that are responsible for both production and reliability and security is operational queries and security queries often cover the same data, but they ask different questions about it. And this is part of what what I want you to take away with is some of these tools are aimed at different kinds of tasks than we have as people responsible for security, but you can use those tools. You can give it, if you add some data to it, you can then make it useful, gain a lot of these benefits. And let's see, we got a tool thing, okay. There is a proliferation of tooling for observability. There are whole startups that are focused on this. There are a lot of open source projects. There's stuff about code understanding. If you go and search for observability on the web, you'll see lots of flashy screen dumps of, dashboards and graphs and charts and things, and aimed at the executive that's going to write the check to go license the product more than the engineer that's going to use it sometimes. But where tools can go beyond that and integrate with your security event and incident management system, integrate with developer tools, so that people don't have to do extra work to make stuff visible either visible into the observability framework or pull stuff out of it. That's the better. Incident management in particular is an area where unifying security incident response and production incident response can be very, very fruitful. That said, in my experience, this works best at small companies where everyone has a fair amount of situational awareness. It does not work as well with huge SRE organizations and huge security organizations coming together. I have stories about that, more appropriate for other venues. But the kinds of defects that cause security problems and cause production problems and cause just bugs in business logic, et cetera, are all very similar. And so you can apply some of this tooling to all of those. You just have to know the right questions to ask. So I've now done a bunch of sort of explaining why the observability as an approach is a good thing. As with everything, nothing is an unmixed blessing. There are costs and benefits. Let's start with some benefits. As I was just saying, you can have better alignment between DevOps and SecOps. If your developers and your security people and your production support are all using the same tools, they're all looking at the same thing. They can just send a link to someone, say, hey, can you look at this? That can reduce a lot of confusion, require many fewer meetings, things like that. The other interesting thing is that given collecting this data, making it available via APIs, being able to issue queries against it is useful for automation as well as people. Just like you can write an alert once you've got data coming in and being stored as a time series, and you can do sort of behavioral alerts, you do the same thing with an observability system, and those can get much more abstract. So you can narrow the scope. You can be pretty specific on, okay, when this very unlikely set of things happens, we get a latency spike on this, trace back to whatever the incoming traffic was. You can write better rules that are more understandable than you can just going just on data. This is also where a lot of organizations are trying to apply machine learning. Once you have this labeled data about what's going on inside your system, it's like, okay, are there patterns humans are not going to see? Looking for things like high latency or error rates or unusual accesses and stuff is something humans are pretty good at. But some of this is pretty subtle, especially if you in a security situation where you have an attacker who's trying not to be seen. So being able to apply larger scale pattern discovery, pattern matching is fruitful, although a lot of this is pretty new. It's exploratory. There are some products out there that say, oh, we're applying ML to observability. This will solve your problems. This will show you what you need to do. They're not. They magnify what humans can do. They free up human attention for the more significant signals, more significant patterns, bring patterns to human attention to act sort of as the exception handler rather than crawling through analyzing all of that data. Many observability systems come with visualization tools that you can use when you need to explain what's happened to somebody in a post-mortem or an executive briefing or things like that, where someone who hasn't had their head stuck in this problem for the last week or the last several hours or whatever needs to know at least the basics of what happened, what the consequences were, what the impact was, what was done to mitigate it. Similarly to that, it's nice when you're sitting down with an auditor for your SOC 2 or FedRAMP or whatever audit, and they ask questions about what your system does. It's really nice to say, well, we have an automated system for that. Here, let me show you. And issue queries, show results, visualize them in a way that they can see, and they can see that it's not someone manually collated a bunch of stuff into Excel and generated a report from that. All of these things are good. There are costs as well. There's a flip side to everything. If you have a system set up where you can do dynamic tracing, for example, where you can start to monitor state or even affect control flow without monitoring a binary, using something like dtrace or BPF, things like that, that's really useful for doing non-intrusive data gathering. But of course, it's also useful it's useful for non-intrusive data gathering by people or agents that you don't want to be able to do that. Some of the capabilities that have been put in place for observability, like kernel tracing, things in standard libraries, things like that, also mean that there are new kinds of malware that are harder to detect, that don't show up if you are doing static analysis of a binary. And so access to some of these capabilities needs to be treated carefully. It's the equivalent of root access in many cases. And so how you deploy it within an organization, how you track use of it, how you detect misuse, it becomes sort of a meta problem. Who watches the watchers is always going to be with us as a challenge. Another aspect that I've seen pop up 2 or 3 times now is it gives you an illusion of completeness. Now you've got this product, it gives you a single pane of glass. It's a buzz phrase that I've been hearing that shows you all your operational state, all of the things you need to worry about, all the things you need to pay attention to, one place. You can feel as though, okay, now I know what's going on. That's usually not true. Systems these days are complex enough that no single person is going to know everything that's going to go on and everything that is in fact significant to them. So if you're looking at adopting some of these tools that have been written by companies or open source, make sure that they can answer the question that you'll need to answer. Make sure it's not just, hi, this is dashboards v2, lots of pretty graphics. Make sure that they can magnify your ability to answer questions, do things that you need to do to find out what's going on inside the system, help you build systems where that comes along. There's an illusion of, well, you'll get observability for free if you adopt our SDK or if you adopt our platform. You know, every cloud platform these days has tracing facilities, has metrics gathering, all of that. Make sure that you can use that. Make sure that you're not just sort of taking it for granted of, okay, this is gathering stuff, I'm all set. And beware of buzzwords of the day. A lot of things have gotten lumped into observability that are kind of log analysis, so traditional log analysis with a new label stuck on it. One piece of advice I have on that is to try things out. Build something, pull over an open source project, deploy it on a sample project. Get a trial from a vendor who wants to sell you their latest observability system, and kick the tires, try it, experiment with it. Do a red team and see if it'll pick things up. If they say, well, we have advanced AI for detecting anomalous access patterns, say, great, let's set it up, and we have a team that's going to go generate some anomalous access patterns. Let's see where you can catch them. Sometimes that works, and sometimes it doesn't. I know of interesting cases of both, but it's a way to validate the claims, because there are a lot of claims. There's a lot of hype around this right now. Backing up a minute, I talked a little bit. I mentioned SDKs. One of the things that is kind of promising is that there's a lot more support these days in SDKs, in platforms, for wiring up observability features, wiring up metrics collection. The days are passing, finally, where you have to go and you have to add, okay, I'm going to add this counter, and I'm going to expose it here, and I'm going to log it to this. Take advantage of those as you're building things. But this can't really bolt anything on. A lot of this does not work for legacy systems. You have what you have. Those systems have outputs. Some of them you can inspect in situ. Some of the capabilities that VM providers, for example, are starting to create, and some of the kernel tracing work in Linux can be used to inspect internal state of legacy apps. But you either luck out or you don't on whether that ends up giving you useful data. Let's see, how are we doing on time? How are we doing? Fine. So that's covering a bunch of security aspects. I mentioned privacy at the beginning. These tools can also be used for privacy use cases where you're more concerned with data and credentials than you are with attacks. You may be looking for, okay, someone's compromised this data, someone has stolen a credential, passing it around, so on like that. The better you have marked your data and metadata in machine readable format, the better these probes and observability tools can leverage that to line things up with other things going on in the system. Not all of this state is sort of runtime metrics. And the flip side of allowing developers to use these tools, the positive side is it's a great debugging tool, being able to see how a big distributed system works and how the logic that they are trying to implement is behaving. If you're exposing data that way, be very careful. I mean, some of this is basic data hygiene, but having the trace probes emit an identifier that's opaque still lets you trace it through the system without exposing underlying data. So going back to the central piece of the approach, which is to frame the problem as, how do I answer these questions when I need to find out what's going on inside the system, rather than firing off an investigation. It does require you to build systems and processes that can answer questions and not just display info. So logs and metrics can come across as being very read-only. They're sort of reporting. Adding queries to that really turns that from sort of a static record of what happened into something that you can work with to understand what's going on right now. And with that, take some questions if anybody has them.
If you do have questions, please come up close so we can catch you on the microphone.
Yeah.
What do you see as the next steps as it relates to logging, monitoring, alerting, integration of all of these solution environments?
What do I see as the next steps? Right now, a lot of the observability products that are out there and projects in the open source land are extending on things that have been built already, building on things like Prometheus and Grafana and time series metric storage, and trying to load, plop machine learning models on those, trying to plop more abstract models on those. I think that's a fairly limited gain. I think that the next step is going to be, there's going to be something that's along the lines of going from logs to storing things in time series so that we can capture behavior, so that we can find the next level of abstraction. I don't think anybody's found that yet. And so I'm very interested in where people get frustrated with the observability tools that we've built now, that, okay, this still doesn't answer my question. I need a way to answer X. And that's going to trigger the next step of, okay, let's pivot our framing from gathering logs and events and traces. What's the next thing past traces? I don't know what that is yet, but there's something, and it's going to be born out of frustration. All of this stuff is a product of somebody getting very frustrated. They have a problem to solve. They can't find the information they're looking for. They want to be able to ask a computer and get an answer rather than tracking down a human and saying, okay, what does this mean? So I wish I had a clear view of what was next there. I think that's an area of active experimentation across the industry. So I'm looking forward to finding out what that is. Yeah.
Have you done any work around making query context better, and/or how can we improve in viewing the not investigation but the query? Have you done anything around how that would be an improved process so we can get better answers from the data?
So the question was, how can we structure the query process so that we can get better answers out of the data? There are a couple different ways to do that. I know that there have been some applications of large database technology, so dumping things into something like Google BigQuery or another sort of large database that can do very rapid queries around huge amounts of data. One example of that relates to observability is deps.dev, which is an experiment being run by Google where every day we crawl all of the major open source repositories and grab all of the dependency data and put that into a database you can query, so that if you want to issue queries against, okay, has the dependencies for this package changed? Has such and such happened? You can issue a query against that instead of having to go crawl it or inspect it yourself. I think there's likely to be more of that as we identify what corpuses of data are useful across organizations to query. Open source dependencies was kind of an obvious target for that. It's a question many people have, especially after Log4j. And people worrying about the next Log4j, things like that. So those technologies have some applicability. They're a little manual now. To use them right now, you exit your observability environment and you go start typing SQL queries at something, or wrap a UI around that. I think the success of those will start to push towards more purpose-built tools. People have been logging stuff into SQL and issuing queries about it forever, but the time series database was definitely a step up from that. I think we're going to see similar stuff for other kinds of signals. I don't know if that answers your question. Okay. Yeah.
Wow, great way to start a question. We talk a lot here about this idea of trying to create unifying, platformy ways to understand all of the data that we have, everything that we have coming in one place. yet it seems like we have a larger and larger proliferation of tools that do specific things.
Yes.
Is that just me not understanding the space, or is it like capitalistic whatever influences, or is there some integration? Like why do we have so much stuff?
Okay, so trying to repeat the question for the stream. Question is, I've talked a bunch about having one unified source of truth for a bunch of teams to be able to query, but it seems like we have more and more of those as time goes on, more and more sources of data, more and more things we have to consult. Why is that? And I think the answer to that is that we don't have that good unified source of truth, and we may never. Teams solve problems and build tools around the problems they're facing. Sometimes having one grand unified platform does not actually make life easier. Those of us who've worked for big enterprises, doing it the one true way can often be harder than just rolling something yourself. I do think that as the analysis tools get better and they allow you to answer questions about the data you are gathering, that provides some incentives for federation, for other kinds of taking all those multiple sources, not necessarily all dumping them into the same store, but being able to query across them and correlate things across them, so that if you have something that's generating timelines and you have something else that's measuring production traffic, being able to do that kind of join, I think is going to be the way to handle that kind of scaling multiple sources. So big joins across multiple data sources is its own research topic in database land, but I think that that's likely to be the most fruitful approach to that. I don't think we're going to, I don't think we're ever going to get to one single source of truth for data, just like I don't think that all, understanding everything going on in a system is ever going to be that one seamless pane of glass. But where we can reduce fragmentation, the better, and where we can move information from one context to another without having a human having to copy and paste it or type in a query, get an ID right, things like that. That kind of interoperability, I think, is going to be what's going to make the biggest difference. Going once? All right, one more question.
First-time attendee, long-time practitioner. What do you see happening with, the big part on the industrial control side that we see right now is somebody goes in and takes over the actual endpoint, the transmitter itself. There's no real way to detect that unless you're comparing that to several other pieces of processing. So kind of back to your who's watching the watcher, if the data looks one way, if someone's taking that over, how are we correlating that? Where do you see coming that's going to start correlating all these pieces together? This is out of range for what we do.
So to summarize the question, what happens when something that's gathering data, so a traceability probe, an observability probe of some sort has been compromised? So something is feeding bad data into your big central store. That's the same problem that we face all the time. How do we detect that something is anomalous? That does touch on the watchers, who watches the watchers question I had. There are levels to this that we have to think about. How do we know that the data we're asking questions over is accurate? How do we audit endpoints? How do we understand if an endpoint is under an attacker's control or someone is misusing the data that we're gathering? I don't think there's anything special about that when it comes to observability. It's the same problem we have with endpoint management in general, with any kind of remote sensor. You can look at the data under and the traffic under your control. You can look at what that remote sensor is telling you, and if they don't match, that's something to flag. And that is something you want to be able to see. So, being able to detect that on your end of it is a good place to put some kind of sensor some kind of probe and feed into your observability system. Like, are we suddenly seeing a bunch of flaky phone handsets, or unusual activity from, or lack of usual activity from laptops or remote systems that are outside of our security boundary, things like that. So being able to answer those kinds of questions is itself an observability use case. But it does highlight the performance of the importance of picking what it is you're going to monitor. You do need to just not. You can't necessarily deduce all of these things from data you think of in advance. And so when something comes up, learn from every incident. Okay, we should be reporting this. We should be gathering this data in addition to this sensor we've already got deployed, so that we can detect when these kinds of inconsistencies happen. And like any kind of automation, it's easier to automate cases that you've already experienced rather than to anticipate, well, what could go wrong in the future. That is a lot of all of our jobs. That's something no one has figured out how to automate yet. All right, well, I took less time than I expected. Sorry if I was talking fast. Any last minute questions? Otherwise, give everybody a bit of a break.